Welcome everyone. In this video, I will talk about function of two variables. In particular, I will highlight the concepts related to limit and continuity. I'll be solving many problems, so you need to watch the video till the very end so that you do not miss any concept. And in case if you are new to the channel, you should subscribe it. So let us first understand what do I mean by the function of two variable. So consider the function of two variable which I represent by z is equal to f of xy. The set of point x comma y in the xy plane for which f of xy is defined is called the domain of the function, and it is denoted by d. The collection of corresponding values of z is called the range of the function. So to understand this, let us look at some of the examples that I already have listed. So here we have a function z is equal to under root 1 minus x square minus y square. So first thing that you can notice that in this case there are two independent variables, that is x and y, and any point that I will be taking here in the xy plane, right, because the input or the domain is the ordered pair kind of point, that is x comma y. So what kind of ordered pair can be taken here, so that we can get with the help of the domain of the function. So how do you get the domain of this function? As you know that domain of the function is the set of all the ordered pair or all the points like x comma y for which this function is well defined. So when this function will be well defined, because we have under root or a square root of this, so this 1 minus x square minus y square should be greater than or equal to 0. So this implies what? That this implies that 1 should be greater than or equal to x square plus y square. And this is nothing but, this thing is nothing but, it can also be written as x square plus y square is less than or equal to 1. So if I am talking about domain of the function basically, if I call this axis as x axis and this axis as y axis, so here we will have a disk whose center will lie, whose origin, whose center, will lie at origin. So all the points over this disk or, on this disk can be considered to be domain, right? So every points which are lying over or inside the circle x square plus y square will be the part of the domain for this function. And if I ask you what will be the range of this function, so for the range, range is that value of z which it can obtain by giving the suitable values of the ordered pair x comma y. So the range of this function will be set of all real number in the interval 0 comma 1. You can clearly see that what is the maximum value that this z can take. We have to subtract 1 minus something. So if you have something like 1 minus x square plus y square, the maximum value it can take when x square plus y square will be equal to 0. Means if I take the point 0 comma 0, then its value will be 1 minus 0 and its value will be 1. So the maximum value that it can take is 1. And if I take a points like suppose something like 1 comma 0 or 0 comma 1, in that case x square plus y square at most can be equal to 1, because x square plus y square is less than or equal to 1. So if I take this is equal to 1, then its value will be 1 minus 1, that is equal to 0. So the range will lie between 0 to 1, right? Now if I ask you that how does this function look like, so I have drawn this graph with the help of internet, and you can see that here let me use another ink so that it is clear. So this is the unit disk in which the function is taking the value, you can clearly see, and the z value is going into the direction of z. So basically this is the y axis and this is the x axis, and in this direction, the vertical direction, we are taking the z axis. So basically whenever you talk about a function in two variable, and suppose you take this axis as x axis and this axis as y axis, and for any point, for example if I take another example that z is equal to x square plus y square, right, and if I take x is x comma y, a point like 1 comma 2, So the value of z will be what? The value of z will be 1 square plus 2 square, that is equal to 1 plus 4, 5. So if I take x is 1, y is 2, so somewhere here, and the value of z, like this is the point that we have in the xy plane. So this is the input here, and what will be the output? So output will be the value of z, so which will lie in the direction of z axis, right? So we are getting a point here. I hope you can clearly see that this is just above this point 1 comma 2, and the coordinate of this point will be 1 comma 2 comma 5. So if you take the collection of all the outputs, what will you get? You will get a surface, right? So function of two variable z in that case gives you a surface. Okay, let us look at some other examples as well here, that if I talk about z is equal to 1 by x square minus y square, then what will be the domain of this function? This function will be well defined when x square minus y square is not equal to 0. So it means what? That y should not be equal to plus minus x, right? So here the domain is the set of all points in xy plane except those points for which y is means we have to remove all those points for which y is equal to x or minus x, means y should not be equal to plus minus x, right? So this is what I have written. Its domain is the set of all point in xy plane such that y is not equal to plus minus x. Suppose I say y is equal to 4 and x is equal to minus 4. So in that case I will get what? I will get 4 square minus 4 square. So I will get 16 minus 16. I will get something like 1 by 0. So this will not be defined, right? So I have to remove all those points like for which y is equal to plus minus x, right? And what will be the range of this function? The range of this function will be the set of all real number. And I would suggest you to think about this, that why I am saying that the range will be the set of all real number, because it can be made as large as possible by taking a suitable value of x and y, and it can also be made as small as possible, both positive and negative. For example, if I take x is equal to 1 and y is equal to minus suppose 50,000, right? So this value will be 1 by 1 minus 50,000 square, a very big number with a negative sign. So it will be like a small number with a negative sign. So similarly we can actually generate any value of z with help of suitable value of x and y. So its range will be the set of all real number. But I would suggest you to think about it, right? Don't believe me, think about it and convince yourself that range will be the set of all real number. Similarly, if I talk about the function z is equal to log of x plus y, its domain will be what? Its domain will contain all the points x comma y for which x plus y is greater than 0. I hope you know that log function is defined for those values of x for which x is greater than 0. So here it is like z is equal to log of x plus y. So x plus y should be greater than 0, and its range will be the set of all real number. Okay. So I hope the idea of domain and range, it is very much similar to the idea of domain and range in case of function of single variable. Only important observation I want to have is that in this case, when we are taking the points in xy plane, then the value of z will point in a vertical direction, and if you collect all the values of z, it will create a surface. Okay. Now this is the main concept that I want to talk about, and that is the concept of limits. So how the limits are defined? First of all, let us look at this rigorous mathematical definition. Sometimes they also call it delta epsilon definition, right? We will not talk much about it, but we will just understand it, and then I will do the problem solving. If you have arrived till here, be till the very end, because the problems are going to come. So let z is equal to f of xy be a function of two variable which is defined in the domain D. I talked about what is domain D. And let p, which is a point given by x0 y0, be a point in D. And if for every epsilon greater than 0, however small, if we can find a delta greater than 0 such that every point xy in delta neighborhood of p x0 y0 mod of f of xy minus L is less than epsilon whenever x minus x naught square plus y minus y naught square is less than delta. And then the real finite number L, this number should be real and finite, is called the limit of the function. Most of you might not have got what I am talking about, so don't worry. Basically, let us understand it like this. Understand it like a layman. Everyone will understand. Even an auto rickshaw driver will understand. If I am writing this, that limit xy tends to x naught y naught of f of xy is equal to L, it means what? It means this, that the difference, the distance or the difference between the function value at xy and the value L can be made as small as you wish if xy and x naught y naught are chosen to be very close to each other. So basically the point is simple, that if x comma y, your points approaches to x naught comma y naught, the function value x comma y will approach to L. That is the meaning, and this is something that has been defined to be a very rigorous kind of definition. So you just simply understand this, that if xy tends to x naught y naught, then f of xy should approach to 0, right? Now I am going to take problems, and then through the problems I am going to explain the concept, right? So to start with, let us take the first problem. Determine the following limit. So when you have to determine the limit, what you do? You first directly substitute the value and check what you get. So if xy tends to 1 comma 1, means x tends to 1 and y tends to 1. So if I put x is 1 here, so I will get 1 square. If I put y is 1 here, I will get 1 square. So 1 square plus 1 square minus 1. So what I will get? I will get 1. So this is the value of the limit. Nothing special about it. Now if you look at the second problem, initially I am taking easier problem and then I will take better problems also. But to be very clear about the concept, you should see all kind of problems. So now all the problems are going to be discussed. All the basic concept and the formalities I already have completed. Now ladies and gentlemen, suppose they are asking determine the following limit if they exist. So first of all, if I have to calculate this limit, I directly substitute the value of x and y and see what we are getting, and we do this mentally. So if I put x is equal to 0 and y is equal to 0, I will get 0 plus 0, means in the numerator I will get 0, and in the denominator I will get 0 square plus 0 square plus 1, so I will get 1. So basically I will get 0 by 1, so I am writing it 0 by 0 plus 0, 0 square plus 0 square plus 1. So here we are getting 0, here we are getting 1, so the answer is equal to 0. Very simple, no confusion. Let us look at this problem, which is slightly better, or it has been asked in different kind of exam, so this is an important problem also. Earlier two problems were very direct, but it can be asked also, no problem. So here we have to concept like you have to calculate like limit xy tends to 0 comma 1, and this is your expression. So when xy tends to 0 comma 1, basically what does this mean? This means that x tends to 0 and y tends to 1, right? So this is a limit which we have to calculate. So what I can do, I can write the given limit as limit x tends to 0, and I'm going to collect the terms of x. So I can write it tan square x by x square, and then we have the another term, that is limit y tends to 1, and when we can collect the terms of y, that is y minus 1 by y square minus 1. So there is a standard limit most of you might have studied in your schools. So limit x tends to 0, and that I am writing for your convenience, that is tan x by x is equal to 1. So here we have x tends to 0, and this is tan x by x whole square, so it can be just equal to 1. So 1 square, so that is equal to 1. And if I calculate this value, here we will write what? I can write 1 into limit y tends to 1, and here I can write y minus 1 divided by y plus 1 into y minus 1. So this term of y minus 1 can be cancelled, and then I will get 1 into, and here if I put y is equal to 1, I will get 1 plus 1, that is equal to 1 by 2. So the value of the limit is equal to 1 by 2. Let us talk about this problem now. I hope I am not speaking too fast, so you are following. Evaluate the limit if it exists. So here, if I have to solve this problem, I am writing here the solution. If I directly put the value of x and y, what will I get? I am doing the calculation mentally, and this is important for you also, that sometimes when we evaluate the limit, like in the previous question, I did not highlight, but let me highlight it again. If you directly put x is equal to 0, so I will get tan 0. So here I will get tan square 0 means I will get 0. Then y, if I put 1, so I will get y minus 1 is equal to 0. And in the denominator, if I put x is equal to 0, I will get 0, and here y square minus 1, so 1 square minus 1 is equal to 0. So I was getting 0 by 0 form. So it means that 0 by 0 form in calculus is known as indeterminate form. So we could not directly substitute the value. So that is why we have separated them and evaluated them separately. But in the first problem, when I was directly putting the value, I was not getting an indeterminate form, rather I was getting a finite real number, right? So if you look at the definition here, in the definition it was highlighted that if I get the real finite number L, then we consider the L as the limit. So here also I was getting the real and finite number 0, so the limit was 0. Now if you do the mental calculation here, just in the rough I am doing, if I put y is equal to 0, I will get 0, and if I put x 0, so I will get 0, and then I have cos of 1 by y. So as y tends to 0, 1 by y tends to infinity, right? So what is the value of cos 1 by y? The value of cos 1 by y, you know the property of cos function, that cos function, any value for any value of input, the cos function can take the value between minus 1 and 1. No matter what is the value of input you give here in cos, I don't know what is the value, but I know for sure that it is going to lie between minus 1 and 1. You have studied about this in your previous classes, that the range of cos x is minus 1 to 1, or cos x lies between minus 1 to 1. Same is true with sin x also. Sin x also lies between minus 1 to 1. So did you notice what I am trying to highlight here? That if I directly put the value, I will get y is equal to 0, I will get x is equal to 0, and into cos of x by y, cos of 1 by y. So cos of 1 by y will be a finite value, value between minus 1 and 1, including both, where both are included, where minus 1 and 1 are included, just to highlight this so that there is no scope of confusion, right? If you ask me what is the value of cos 1 by y, I will say I don't know, but I will certainly tell you that it will lie between what? Either it will be minus 1 or any value between minus 1 and 1. So it will be a finite value. So if you write 0 plus 0 into any finite value, you will get 0. So 0 plus 0 is equal to 0. So the limit value is 0 here. Okay? Getting all good up to now? If you have got the things up to now, press the like button. This is what they tell you, na? So in maths also, if you are enjoying the video, press the like button. Okay, but before that, let us solve this question. So here, evaluate the limit if it exists. So again, as a smart student, I can do the calculation mentally. So I am going to put x1, so I will get 1, y minus 1, so I will get minus 1, so 1 and minus 1, I will get plus 2, and then x minus 1, 1 minus 1, 2. So I will cancel, or in case if you some of them can also factorize it, but there is no need to factorize. I can directly write 1 cube minus 1 cube by 1 minus 1. So I will get what? I will get 1 plus 1 by 2, right? So 2 by 2, that is equal to 1, right? So the value is 1. This has been asked in earlier exam also. Now this question is a very important question, and here I will introduce the very important concept which I have not highlighted till now. So this concept that I am going to talk about is the main concept of the limit. If you remember, and I could have highlighted it earlier also, I missed it, but let me highlight it now. If I ask you, ladies and gentlemen, first let us talk about certain things. So suppose I ask you that if I calculate the limit x tends to a f of x, and if I ask you that this limit exists, it is a limit of one variable. So from your previous class you know that this limit exists. It means what? That left hand limit means limit x tends to a minus f of x. This is known as the left hand limit, and limit x tends to a plus f of x, which is known as a right hand limit, and both of them, that is the left hand limit and right hand limit, should be equal. So if you are calculating the limit in case of function of one variable, and you have to calculate the limit of the function when x is tending to a, you have the point a here. But when you are approaching to the point a, there are only two ways to approach to the point a. You can approach to the point a from the left of it or from the right of it. So when you evaluate the value at a by approaching the value of a from the left of it, you call it the left hand limit. And when you evaluate the value at a by approaching the value of a from the right of it, you call it right hand limit. And in case both of them are equal, you say that limit exists. But if I extend the argument here, that if I am calculating the limit of something like x comma y tending to a comma b and f of x comma y, so what is the situation here? The situation here is that we have a point a comma b somewhere in the xy plane. Let us consider it a comma b. Now how can you approach a comma b if you are in the plane? On the line, if you are approaching a, you have only two directions, either from the left of it or from the right of it. But if you are approaching a comma b in the plane, you can approach in this direction, or you can approach in this direction, or in this direction, or in this direction, or in this direction, or in this direction. And some of you possibly may be a kalakar, and you approach by dancing and singing, something like this, right? Some of you may approach like this, that you are a very random kind of person. You are not interested in simple approach. You are approaching like this. The point I am trying to highlight, that there are infinitely many ways in plane to approach to any point. So for the limit to exist, the value of the limit should be same irrespective of your path of approach. I repeat it. This is the most important point I am highlighting. When do you say that limit xy tend to a comma b f of xy exists? There is a definition, a rigorous mathematical definition I have talked about here, but I told you that it might not have made much sense to you. But as a layman, if you look at this, what basically you have to understand? You have to understand that the value of the limit should be independent of the path of approach. Here there were only two possibilities, so you equated that both of them should be equal. But here there are infinitely many possibilities, so it should be equal for all possible paths of approach. It should not be different for any two paths of approach. Are you getting it? So the important observation here is that if I can somehow show that the limit value is different for two different paths, then we can conclude that the limit does not exist. I repeat the argument very slowly once again. The argument is simple, that whenever you are calculating the limit in case of function of two variable, what you need to do? You need to calculate the limit, and you have to ensure that the value of the limit is same irrespective of the path of approach. So I write this because this is so important. I should write that limit should be independent of path of approach. Okay, ladies and gentlemen, I hope till now it is clear. Now this concept I am going to highlight through the multiple problems. So now let us solve this problem to understand the point that I was just trying to highlight. Now if you have to evaluate this problem, they have already written that so that the following limit does not exist. Even though if they ask us to evaluate, I can approach it like this. So here actually what is the point that I have to approach to? I have to approach to the point 0, 0. So to approach to the point 0, 0, I can walk along a straight line which is passing through origin, something like this, right? I can walk along either this path or this path or this path. So all the lines which pass through origin, they can be represented by an equation which is y is equal to mx. So what I am going to do to evaluate the limit, I am going to take the path y is equal to mx, right? And it is also important to note here that can we take this path? Yes, we can take this path, because if we approach x to 0, y will also approach to 0. So if I walk on this path and if I am approaching the value of x to 0, then y will also automatically approach to 0, because this path is y is equal to mx. So this limit, which is originally limit xy tends to 0, 0, xy by x square plus y square. If I walk along this path, means I am fixing y is equal to mx. So in place of y, I am going to put mx. And since x tends to 0, y also tends to 0. So the point xy tends to 0, 0 can simply be replaced by x tends to 0. Because if x tends to 0, then certainly y also tends to 0. So this will be like limit x tends to 0, x and yx is m into x divided by x square plus m square x square. So this can be evaluated limit x tends to 0, m x square and 1 plus m square x square. So this x square and x square cancel, and what we get is equal to m by 1 plus m square. So did you notice something very important, that the value of the limit is m by 1 plus m square? It means what? That it means this is not something that you have to write as a solution. I'm just trying to explain and using a different color. Suppose I take the path y is equal to x, means here the m value is equal to 1. Then the limit value will be 1 by 1 plus 1 square, that is 1 by 2. If I take the path y is equal to 2x, that is m is equal to 2. So the limit value will be 2 by 1 plus 2 square, that is 2 by 5. Similarly, if I take different values of m, I will be getting different values of the limit. But what I was highlighting, I was highlighting that limit exists when it is independent of the path. No matter which path you are taking, irrespective of the path, if you are getting the same value, then you say that limit exists. So here what I will write, here we note that, and here I am writing we, not I. We note that limit is dependent on the value of m. So it is not independent of path of approach. So the limit does not exist. I will not write this detail in the coming question. You have to write this detail, but whenever we will see that limit is depending on the value of m, we will write this thing, that the limit does not exist. Okay. See, there is one very important point, and this is the gist of this. So listen it very carefully. What I am saying, that I have taken the path y is equal to mx, but do you think y is equal to mx is the only kind of path we can take? There is multiple other path also. Y is equal to mx is also infinitely number of paths, but I could have taken path like y is equal to mx square also. I could have taken path like y is equal to mx cube also. I could have taken the path like y is equal to sine x also, because if you take y is equal to sine x and x tends to 0, y also tends to 0. So there are different paths, like someone can approach, as I told you earlier also, someone can approach like this, someone can approach like this. So there are different ways to approach. But the moment I have got two different values of limit, if I am taking this path, I will conclude that the limit does not exist. But if we are getting same value of the limit for this path also, then also we cannot calculate that limit exists. This is a tricky situation I am highlighting. I am saying that if limit is dependent on m, certainly it does not exist. But suppose I take the path y is equal to mx and I get the limit value is equal to L, right? So if I get the limit value equal to L, in that case we cannot calculate we cannot conclude that limit will be equal to L. Why? Because we have taken just one kind of path. What about other path? Examples do not prove anything. This is the important point. But counter examples prove things. So even though if you have taken y is equal to mx, which includes infinitely many paths, still we cannot conclude that this will be the limit value. It will become more clear in the coming problems. So let's be focused. Now look at this problem. They are saying so that the following limit does not exist. So how will you solve this? So let us quickly evaluate this limit. Someone is like knocking somewhere, disturbing me, not allowing me to shoot the video. But I will continue, no one can stop me. So that the following limit does not exist. So how to calculate that, or how to show that? So here also we are approaching to the point 0, 0, and you have got a sense that how I can show it. So I would suggest you to pause the video and try to show that the limit does not exist. So to show that limit does not exist, what I am going to do in this particular problem, I am going to take the path y is equal to mx square. And if I take the path y is equal to mx square, you are very clear that if x tends to 0, then y tends to 0. So this path can be taken, right? Why I am taking mx square? Because we have something like a square root. So this problem will change into what? This problem will change into limit x tends to 0. I am reducing it to just one variable, and x and y is equal to mx is under root m, and a square root of x square is equal to x divided by x square plus y is equal to m x square, right? So I will get what? I will get limit x tends to 0, and here I can take x common. I will get 1 plus under root m, and here I can take x square common, and I will get 1 plus m. So this x and this x square is cancelled, and if you take x tending to 0, we have this. Let me write one more step so that you don't get confused. You write limit x tends to 0, and we have something like 1 plus under root m by 1 plus m, and then you have something like 1 by x here. So if x tends to 0, this will tend to what? This will tend to infinity. So as we have told you earlier in the definition, and I want to show you once again, in the definition I have told you that the L should be the real finite number L, right? But the value of the limit that we are getting here is infinity, right? So since the value is infinity, I will say that the limit does not exist. Limit does not exist. Again he is disturbing me. Okay, let me continue. Now look at this particular problem. I repeat it. If you get infinite value of the limit, it means limit does not exist. Now look at this value. Evaluate the limit if it exists. And here this is a very, very important question for your understanding. And I am going to solve it in two different ways. And I am going to tell you that which method is correct. So this is the most important question. Listen it very carefully. Evaluate the limit if it exists. So first of all, I don't know whether the limit exists or does not exist. They are asking me to evaluate. And as I have told you, that first thing that we should do, that we should directly put the value of x and y. So if I do so, I will get 0 by 0, right? So it is an indeterminate form, so we can't directly put the value. Then just to check whether the limit exists or not, I can take a path again like y is equal to mx, but what I am going to do is not necessarily the correct thing, but for explanation purpose I am doing, and some of the student will make this mistake here. So listen carefully, and this is the main point. So suppose you take the limit path like y is equal to mx. So this limit will change into what? This limit will become limit x tends to 0 and 2x to the power 4 plus 3 and and then y to the power 4 is m to the power 4 x to the power 4 and divided by x square plus m square x square. So this will give me what? This will give me limit x tends to 0 and x to the power 4 can be taken common. I will get 2 plus 3m to the power 4 divided by x square and 1 plus m square. So this x square and x to the power 4 will be cancelled. I will get x square here, and if I put x is equal to 0, I will get 0 into this, so I will get 0. So you can say that the limit is equal to 0, right? And most of the student will conclude that the limit value is equal to 0. Actually the answer is 0. This is the value of the limit, yes, but can we conclude that limit is 0 by just this approach? Take a pause and think about it. The answer is no. Why no? Because as I have told you in the definition, that for the limit to exist, it should be path independent. So you will say, sir, it is path independent because we are getting 0. It is not dependent on m. Whatever be the m, the value will remain 0. But the question is that I have just taken one kind of path. There may be thousands and millions and infinitely many other paths. What about them? Have you verified them? Have you checked for them? So if you have not checked for them, how can you be sure that for those paths also you will get the value 0? Think about it. Can you be sure? You have just taken the path of kind y is equal to mx. These are the paths that you have taken, all the straight lines. But what about this kind of path? You are drunk and you want to approach to this point. You are walking, haphazardly. That is also a path of approach. Have you verified it for this path? I don't know what this path will be, but you have not verified for that. So then you will ask, then what to do? Then what I am going to discuss is important. See, what I can do, I can change this problem into polar coordinate system. And how to change it into polar coordinate system? I will take x is equal to r cos theta. So this is not the right approach. What is the right approach? That I am explaining. X is equal to r cos theta, y is equal to r sin theta. And what is r here? I hope you know in polar coordinate system, r is given by under root x square plus y square. Now the important observation is that I hope you know that if x comma y tends to 0 comma 0, no matter which path you are taking, which you are taking this path, or you are taking this path, or you are taking this path, or you are taking this path, you are taking this path. I also hope you know that if there is a point like x comma y, and I am saying its coordinate is r comma theta. So basically what is r? R is the distance of this point from origin, right? So and theta is this angle which you take measure in anti-clockwise sense. So if you are coming closer to origin, then r will approach to 0 no matter which path you take. You agree? Here if I am saying that if you are approaching to 0, xy approaching to 0, then certainly r will approach to 0. Either you see it through figure or through this expression that r is equal to under root x square plus y square. and if x and y both approach to 0, certainly r will approach to 0. And this will be true for all kind of possible path, not for y is equal to mx or for y is equal to any other path. It will be true for all kind of possible path. So now I am going to write it further. So this limit, if I make this substitution, can be reduced into what? If x comma y tends to 0 0, then r tends to 0. So this limit can be written as limit r tends to 0, and here I will write 2 r to the power 4 cos to the power 4 theta plus 3 r to the power 4 y to the power 4 is sine to the power 4 theta divided by r square, and in the bracket you will get cos square theta plus sine square theta. Now it is very clear that I can write it limit r tends to 0, and here r to the power 4 can be taken common. In the bracket you will get 2 cos to the power 4 theta plus 3 sine to the power 4 theta, and cos square theta by plus sine square theta is equal to 1, so it will be r square. So r square and r to the power 4 cancel, I will get r square. So if I put r is equal to 0, I will get this is equal to 0. So here the limit value is 0. So the answer is, what is the limit value? The limit value is 0. Through this approach also I got the limit value 0. But this approach is not correct because it will not include all kind of path. But if I change it, and I also want to highlight that this is not a path I have chosen. I have just changed the system from Cartesian to polar. So irrespective of the path you choose, you will always get the limit value 0. Pause, think, and comment in case of doubt. Now if you have arrived till here, I am going to take many other problems, so be till the very end. I just want to show you. I will also talk about continuity, and since you have realized that different kind of problems are there, it requires different approach, so be with me. So the next is, so that the limit does not exist. And to show that something does not exist, I just have to find two possible paths for which the limits values are different. So how to do that? Here I can take let y is equal to mx. So if I take y is equal to mx, this limit will reduce to limit x tending to 0. In place of x I will write x. In place of y square I will write x square plus m square x square. Okay, so I will get what? I will get limit x tends to 0, x by x common and 1 plus m square. Here x square will be common. When you take it out of the square root, you will get what? You will get x. So this x and x cancel. Now it is free from x, so the value will be 1 by under root 1 plus m square. So you can clearly see that the limit depends on m. I am not writing this. What you have to write? Here we note that since the limit depends on the value of m, so it is not path independent, hence limit does not exist. Ladies and gentlemen, let's move to the next question. So this we solved. Are the same question? 13? Yeah, they are same question. Sorry. Let us move to the next. This is a very important question, and it requires a different approach. So that the following limit does not exist. Okay, so how will you show? Here you can't take the path like y is equal to mx, because here the value of x comma y is tending to 0 comma 1. So if you take something like y is equal to mx, if x tends to 0, y also tends to 0. But you don't have to reach to 0 0, you have to reach to 0 comma 1. So to solve this, what I am going to do, I am going to solve it in a very different way. So I am going to take a path which is very kind of different. So what I am going to do here, actually we have to approach to the point 0 comma 1. So where is the point 0 comma 1? This is the point 0 comma 1. So what I am going to do, I am going to take a line. And what is the line? This line is parallel to x-axis, and equation of this line is y is equal to 1. And I am going to approach this point 0 comma 1 in two different ways. One, along the same line from the right, and on the other side I will approach to the point 0 comma 1 on the same line from the left, and then I will see how the limit will be calculated. So suppose I walk on this line and I approach to 0 comma 1 along what, along the line y is equal to 1 from left. So this limit, I write it, limit x comma y tending to 0 comma 1 tan inverse y by x can be written as limit x tends to 0 minus tan inverse y I have fixed 1, so 1 by x. You may ask me, what is this 0 minus? It is just a symbolic way of representing that I am approaching to this point from the left of 0, means from the left. Now the point that I want to highlight is that if x tends to 0 minus, 1 by x will tend to minus infinity, right? And so what this will become, this value will become limit, or if I directly put, I will get tan inverse minus infinity. And what is the value of tan inverse minus infinity? The value of tan inverse minus infinity is minus pi by 2. Do you remember the graph of tan x? In your high school you might have studied the graph of tan x. This is the point pi by 2 and this is the point, if I take minus pi by 2, then the graph of tan x looks like this, right? So you, when your value is minus infinity, it is corresponding to minus pi by 2. And if you approach from the right, let me change the color. So if I approach the limit, approach 0 comma 1 along y is equal to 1 from right. So in that case, what will be the value? So this limit will change to limit, this limit I am not writing, x tends to 0 plus from the right tan inverse y is equal to 1. So I will write 1 by x. Now this value will be what? If x tends to 0 plus, right, then 1 by x tends to infinity, plus infinity. So I will get what? I will get tan inverse plus infinity, and tan inverse plus infinity will be equal to pi by 2. So what did you notice? On one side you are getting the value minus pi by 2, on the other side you are getting the value pi by 2. Means you are getting two different values of limit for this different path. So it means what? That it means the limit does not exist. You can write this line that since the value of the limits are different for these two different paths, so the value of the limit does not exist. Okay, you may ask me, what about other paths? I give a damn. I don't care, because the moment I have got two different values for two different paths, I ignore all other paths. This is one of the most or very important question that I am going to solve, and this is a similar kind of question which has been asked multiple times. So I would first suggest you to do the substitution y is equal to mx and then tell me what you are getting. So let's do it yourself. I am not going to show you. They are saying that so that the following limit does not exist. So in this kind of problem, if you take y is equal to mx, you will get the value of the limit 0, right? I just show you because otherwise you will be confused. So if I substitute, and this is not the right approach, that is why I am trying to highlight. So if I take y is equal to mx, the limit will change to what? The limit will change to x tends to 0, x cube into mx divided by x to the power 6 plus m square x square. So this value will be like limit x tends to 0, and I will get m x to the power 4, and from here I can take x square common. I will get x to the power 4 plus m square. So this x to the power 4 and x square is cancelled. I will get x square, and if I put x is equal to 0, I will get m into 0 by 0 to the power 4 plus m square. So basically I will get 0. So the answer is that whether the limit value is equal to 0, the answer is no. You may say that, sir, here I am getting value 0, so limit is independent of the path, so the limit value is 0. But no, it is wrong thing. Why? Because I have just taken one kind of path, y is equal to mx. What about some other kind of path? So you may ask me, what kind of path? So suppose I say that let I take a path y is equal to mx cube. So if I take the path y is equal to mx cube, and here also you note that if x tends to 0, y will tend to 0. So that kind of path can be taken. So this limit will reduce to what? This limit will reduce to limit x tends to 0, and x cube into, in place of y, I will put mx cube divided by x to the power 6 plus m square x to the power 6. So this limit will become what? This limit will become limit x tends to 0, m into x to the power 6 by x to the power 6, 1 plus m square. And now you are smart enough to see that x to the power c can be cancelled, and the value of the limit will be m by 1 plus m square. Now this value of limit depends on the value of m. So the same thing I will write that I have written in the previous problem, that since the value of the limit depends on the value of m, so the limit does not exist. So you will write this, that here we note that the limit is dependent on the value of m, so the limit does not exist. So this is a popular type of question because they may change it as per the requirement. Like suppose I write another question, limit x comma y tends to 0 comma 0, and here I write x to the power 4 into y by x to the power 8 plus y square. So in this case you have to take the path like y is equal to mx to the power 4. If I take for example another problem, suppose I take example this problem, that limit x comma y tends to 0 comma 0, and here I write x to the power 10 into y by x to the power 20 plus y square. So you are smart enough to guess that here you have to take the path m x to the power 10, and then you can get the limit which is dependent on m. So we have done different kind of problems of limit. Now I would like to end the continuity portion also in the same video, so it will be slightly long, so let us be with me till the very end. So what do you mean by continuity? So if we have a function z is equal to f of xy, it is sad. Why the function is sad? It is not sad, it is sad. Function is not sad, function is happy. So a function z is equal to f of xy is said to be continuous at a point x0 y0 if f of xy is defined at the point x0 y0. That is the first requirement. Second requirement is that the limit of the function at the point x0 y0 should exist. And the third requirement is that if the limit exists, and it should be equal to the function value at that point. So if all these three requirements are fulfilled, we say that function is continuous at the point x0 y0. I will take problem, don't worry, it will be clear. If function is defined and limit exists, but the third condition is not satisfied, that function value is not equal to limit value, in that case the point x0 y0 is called a point of removable discontinuity, because what we can do, we can redefine the function in such a way that it becomes equal to the limit value of the function, and in that case the function will become continuous, right? So let us take few problems to understand this. So the first question they are saying that so that the following function, I mean there is just one function, are continuous, not are is continuous, because I have just taken one function, English class, is continuous at the point 0 comma 0. So how do you prove that it is continuous? So let us look at the requirement. First requirement is that function should be defined at the point 0 0. So I am writing the solution, and let us solve it point by point. So first point is that whether the function is defined at 0 0. So yes, it is defined, because here there is a small thing I can write, if xy is not equal to 0 and if xy is equal to 0 0. Let me write it so that you don't get confused, and here you can write 0 comma 0, because by 0 I mean the ordered pair 0 comma 0. So the function is given by this when xy is not equal to 0 comma 0, and it is equal to 0 when xy is equal to 0 comma 0. So what is the function value at the point 0 comma 0? The function value at point 0 comma 0 is equal to 0, means the first condition is met. So what is the second condition? We have to calculate the limit x comma y tending to 0 comma 0, and for the function, since it is approaching to 0 comma 0, it is not equal to 0 comma 0, so I have to take this function. So I will take 2x to the power 4 plus 3y to the power 4 by x square plus y square. And this problem I have already done, if you remember, so I'm not going to take too much time. I will make it very quick. So I will take x is equal to r cos theta, sorry, x is equal to r cos theta, and y is equal to r sin theta. So this limit will change to and as x comma y tends to 0 comma 0, then r will tend to 0. So this limit will reduce to what? This limit will reduce to a limit r tends to 0 to x to the power 4, that is r to the power 4 cos to the power 4 theta plus 3 r to the power 4 sin to the power 4 theta divided by x square plus y square, that is r square cos square theta plus sin square theta. So this r to the power 4 will be common, and here r square will be common. That will cancel and you will get r square into this thing, which will become 0, right? So the limit value is equal to 0. So what is the third condition? Third condition is that f of x comma y, that was the function value, which is equal to 0, and this is also equal to the limit value, limit x comma y f of xy. So all these three conditions are satisfied. So it means that function x comma y is continuous at 0 comma 0. So if you basically know how to evaluate the limit, you can very easily also prove the questions related to continuity. So we have another question that so that the following functions are continuous at the point, and I thought again here it is age is continuous at the point 0 comma 0, and here also you can write xy not equal to 0 comma 0 and xy is equal to 0 comma 0. So take the screenshot of this, solve it. I am not going to solve, this is your homework exercise, right? Because it is a similar problem, I possibly believe that you will be able to solve. I am going to solve this problem, and in all this there is something that I need to correct. It is 0 comma 0 and it is also 0 comma 0. So that the following function and are continuous at the point 0 comma 0. So I am talking about one function at a time, so again it is each continuous. So how to solve this? This is a different kind of question, so I am going to solve it. And I would expect that you solve this question and let me know that what is the limit value you are getting, and whether you are getting the limit value 0 or not, or whether the function is continuous or not. So I'm going to solve two more problem. One is this, the one which I have highlighted, and there will be another homework problem for you, and this will be another homework problem, and this will be another, and I will solve this one, the last one, which will be the very important. So the last problem is my favorite, most loved problem. So I'm going to solve this in the last. So let us talk about this, and this is also one of my favorite problem. So we have to prove that the following function is continuous at the point 0 comma 0. So what is the first thing we have to check? We have to check whether the function is defined at 0 comma 0. So yes, at 0 comma 0 the function is equal to 1 by 2. What is the second thing I have to check? We have to check that limit x comma y tends to 0 comma 0, and that is f of xy. Because we are approaching to 0 comma 0, I have to take this function. So I will write sine inverse x plus 2y divided by tan inverse 2x plus 4y. So this is an interesting type problem. So you see that here we have x plus 2y and here we have 2x plus 4y. So to evaluate this, what I am going to do, I am going to take let x plus 2y is equal to t, and as you can see that if x comma y tends to 0 comma 0, then t will also tends to 0, because t will become 0 plus 2 into 0, so t will also tends to 0. So this problem can be reduced in just single variable, limit t tends to 0, and here it will be like sine inverse t by tan inverse 2t, right? Sine inverse t plus tan inverse 2t. Now if you put 0 directly, it will become 0 by 0 form. So this will become 0 by 0 form. I hope you understand this. So when it is 0 by 0 form, what we can do, either we can using a standard limit, or we can use L'Hopital's or L'Hospital's rule. You know that. So how to use that? You can take limit t tends to 0, and sine inverse t, if you differentiate, you will get 1 by under root 1 minus t square. This can be also done by using the standard limit, but I prefer L'Hospital's or L'Hopital's rule because it is kind of more general. And here if I differentiate, I will get tan inverse derivative is 1 plus tan inverse x gives you 1 by 1 plus x square. So in place of x we have 2t, so it will become 4t square, and we have to differentiate 2t, so I will get 2. So if I put the value of the limit here, I will get 1 in the numerator, and here I will get 1 by, this will become 1 plus 0 1, so I will get 2, so I will get 1 by 2. So the limit value is equal to 1 by 2. So what did I notice? I noticed that limit x comma y tending to 0 comma 0, and if I evaluated f of xy, that is equal to 1 by 2, and this is also equal to the function value at 0 comma 0. So we conclude that the function is continuous at 0 comma 0. So we are already almost 1 hour in the video, but before I end, I want to discuss that interesting problem. So please solve this problem also, that it is continuous at the point 0 comma 0. Easy problem. Take a screenshot of this, or pause the video, note the problem and solve it. You can solve this also. So what you have to do, you have to pause and take the screenshot or write the question and then solve. I am doing this because in one of the videos someone requested me that provide some good questions also. This is also a very simple question. You should try to solve it. But this is my favorite question, and I would not let this question for you to solve because you may face certain difficulty. So we have to check the continuity of this function at the point 0 comma 0, and I don't know whether it is continuous or not, so for that I have to check. So I am going to solve it step by step. So what is the first step? First step is that we have to check the continuity at the point 0 0. So we have to check whether the function is defined at the point 0 0. So if I take f of 0 0, it is already given is equal to 0, so the function is defined at 0 0. Second condition is that we have to evaluate the limit x comma y tending to 0 comma 0, and f of xy, because it is tending to 0 comma 0, it is not equal to 0 comma 0, so we have to take this function. So I take 1 by 1 plus e to the power 1 by x plus y square. And how to evaluate this? This is interesting. So to evaluate this, I am again going to take two very special paths, and for that I am drawing this diagram here. So suppose we have this axis system, which is x-axis and y-axis. So to what I am going to do, I am going to approach to the point 0 comma 0 through two different paths, and one path is that I will be walking along the x-axis from the right of it. So means I will fix the y value to be 0, because what is the equation of x-axis? The equation of x-axis is y is equal to 0. So I am going to approach to the point 0 0 from the right, and then I will also approach to the point 0 0 from the left by fixing y is equal to 0. So let me change the original color. So I already have explained. So from left, approach from left along y is equal to 0. So this limit will become what? This limit will become limit x tends to 0 minus, because we are approaching from the left, right? And y I already have taken 0, so I will write 1 by 1 plus e to the power 1 by x and plus 0 square. Now understand this very carefully. If x is tending to 0 minus, 1 by x, as I have explained earlier, will tend to minus infinity. And here we have e to the power 1 by x. So e to the power 1 by x, which is basically e to the power minus infinity, this will tend to 0. I hope you know that e value is 2.7 something. It is greater than 1. So e to the power minus infinity is basically 1 by e to the power infinity, and it will become infinity, so this will approach to 0, right? So it will become what? It will become 1 by 1 plus 0, so it means its value is equal to 1. And if you approach from the right sorry, so approaching, I am writing it, approaching from right. So if I approach from right, this limit will become what I am writing here. This limit will become limit x tends to 0 plus and 1 by 1 plus e to the power 1 by x plus 0 square. Now the explanation is that if x tends to 0 plus 1 by x tends to infinity and e to the power 1 by x is equal to e to the power infinity, this will also tend to infinity. So here I will get what? Here I will get 1 by 1 plus infinity. It is 1 plus infinity, and 1 plus infinity, I hope you understand, is equal to infinity, because if you add any finite quantity to infinity, it will remain infinity. So this will be equal to 1 by infinity, means it will approach to 0. It will be equal to 0. It is not right to write equal, but I hope you understand. I can just directly write that this value is equal to 0, right? So to avoid any confusion, because some people are very fussy about this infinity being not equal, rather approaching. So I'm just writing directly here. I hope you are clear about the explanation. So explanation is, again I repeat, that if x tends to 0 plus 1 by x tends to infinity, e to the power 1 by x is equal to e to the power infinity, that will tend to infinity. So here I will get 1 by 1 plus infinity. 1 by 1 plus infinity is 1 by infinity, and 1 by infinity is equal to 0. So if I am approaching to the point 0 0, from the left I am getting the value equal to 1, and if I am approaching from the right, I am getting the value is equal to 0, right? So what did I notice? I noticed that the value of the limit does not exist. So the second condition is not met. So the second condition is not met, so limit does not exist. So function is not continuous at 0 comma 0, right? So in this video I talked a lot of problems of different kind, different level of difficulty, and different approaches, and we have discussed many problems. I have left some problems for you also to solve. In case if you feel like that this video you have enjoyed, like the video and share with all your friends. Other videos related to the partial derivatives will be uploaded very soon, and then possibly in the next few days I will complete all the second variable related video. So this video actually covers almost 2 of your lecture. Thanks for watching and have a very great day.